So now let's look at taking this concept one step further. What is the mass of 4.78 times 10 to the 24th nitrogen dioxide molecules? Now notice that a specific unit is not given here, but it's always assumed that you're going to solve in units of grams. And then if a different unit is required, then it will specifically ask for it. So let's look. We're given molecules of nitrogen dioxide and we want mass. So this is where we're starting over here with a pure number of molecules. And we've got to get over here to mass. So the way to do that is to get from numbers to moles, and then once we're at moles, we can get to mass. However, remember on this side, when we're going in between mass and moles, we always have to calculate our molar mass. So let's go ahead and take the time to do that. So in a mole of nitrogen dioxide, there is 1 mole of nitrogen, and 1 mole of nitrogen has a mass of 14.01 grams. There are also 2 moles of oxygen, and each oxygen mole has a mass of 16 grams. So 2 times 16 grams is 32 grams. Here is our molar mass. Now we have the information we need to do our calculation. Okay, so here's our given number of molecules. We want mass. Here's our conversion factor that allows us to get to mass. For moles and mass, our molar mass. If we look at doing our unit check, we're missing a conversion factor. We also need a conversion factor that gets us from number of molecules, and that's Avogadro's number. Okay, so here I have molecules of NO2, here I have molecules of NO2. Here I have mole, here I have mole, here I have grams, and then of course our mass is always going to be in unit of grams unless it otherwise specifies. Since I have 2 of each unit, I can go ahead and do my railroad math. Now this may be very tedious, but it is very, very important to write down all of your units, because it makes a big difference whether something's down here or something's up here when you do the math. Dividing is not the same as multiplying, and you'll get a very wrong answer if you don't place your units in the correct place. So we're given 4.78 times 10 to the 24 molecules of NO2. I have molecules here, molecules need to be down here. So that's 6.022 times 10 to the 23 molecules of NO2. And that's equal to 1 mole of NO2. Okay, so I always make sure that my units cancel out before I go any further. A lot of times I catch myself in mistakes at this point. Alright, I have mole here, so I need mole down here. And this is the conversion factor I'm going to use. 46.01 grams of NO2 is what goes on top. My moles of NO2 cancel out, and I have grams of NO2, which is exactly what I want. So now I'm going to let my calculator do the math. And my calculator tells me 365.2072401, and that's going to be grams. Okay, does that make sense? Let's see, I have an order of magnitude approximately more than a mole here. Instead of 10 to the 23, I have 10 to the 24. So here I have almost a magnitude more than, and by magnitude I mean power of 10, greater than a mole. A mole is 46, and this is almost 400 grams. So yes, that makes sense. My number makes sense. Now one thing you want to look out for is a mass where you have a very, very large exponent. The mass of planet Earth is about 10 to the 24th kilograms. So if you're getting a mass of 10 to the 23rd or 10 to the 24th grams, that's almost as massive as the planet. So you want to look out for that. You're not going to get masses that are this big unless you're talking about planets. So my answer makes sense. Let's look now at my sig figs. I have 3 sig figs. My answer should have 3 sig figs, and that's exactly where my decimal point is. My last allowable digit is 5. 2 means I don't have to round, So 365 grams of nitrogen dioxide is my final answer. Now let's look at this problem. How many formula units are in 50 grams of lead-4 oxide? And remember, we've already figured out the molar mass of lead-4 oxide. It's 239.2 grams. And also remember that the term formula unit is used for the smallest whole number ratio of cation to anion, because ionic compounds aren't made of molecules, so we can't talk about the smallest unit in terms of molecules. So we use the term formula unit. So pause this lecture and see if you can work this out. And when you're done, restart it and we'll go over it. So let's see how you did. First, we want to write down what we're given. We're given 50 grams. We want the number of formula units. Now, we've already worked with this compound before, and we calculated its molar mass. So we know that 1 mole of lead-4 oxide is equal to 239.2 grams of lead oxide. And then this gets us from mass to moles. And then to get to an actual number of formula units, we use Avogadro's number. Remember, Avogadro's number to get a number. So 1 mole of lead-4 oxide is 6.022 times 10 to the 23 formula units of lead-4 oxide. So we have 2 of each unit, 2 grams, 2 formula units, 2 moles. We're ready to do our railroad math. So let's look at the setup. I'm given 50 grams, so grams must go down here to cancel out. And that's where we use our molar mass. So our grams of lead oxide cancel out. Now I have moles of lead-4 oxide up here, so I need moles of lead oxide down here for those to cancel out. And then I'm left with the units of formula units, which is exactly what I want. Then I'm going to let my calculator do the math, multiply by what's on the top, divide by what's on the bottom. And my calculator tells me 1.258779264 times 10 to the 23. Okay, before I go any further, does this make sense? This is a huge number. Let's look at my units here. Yes, it does make sense. When we have a huge number, we're talking about number of atoms, ions, formula units, or molecules. So since I'm talking about formula units, this makes sense, 10 to the 23. This is less than a mole. A mole is 6 times 10 to the 23. This is less than a mole. But 50 is less than a mole as well, so this all makes sense. Now let's take a look at sig figs. I should have 3 sig figs. Here's my last allowable sig fig. I look to the right, that's an 8, so it's going to round up. So my final answer, correct sig fig, is 1.26 times 10 to the 23 formula units of lead-4 oxide. So if you got this right, good job. And if you didn't, just pay attention to where your mistakes are. It's really not that complicated. It just takes a little bit of practice and thinking about what you're actually doing.